Young people, welcome back. BMB in the house, y'all. Ready to get it going. Check it out. We are at the end of chapter 1. Let's see what we got going on today, guys. Chapter 1, lesson 8, interpreting graphs of functions. First objective, interpret intercepts and symmetry of graphs of functions. Second objective, interpret positive, negative, increasing, and decreasing behavior, extrema. Woo, that's a lot. So, I know I didn't finish reading the whole thing, guys. That's because you already know me. Swab at. Students will be able to interpret a graph. There's a lot of vocabulary in there that we're going to talk about for a little bit, but honestly, guys, we got a real easy one today. It's going to be a lot of pauses because I want to make sure I can give you good information on what's going on with these graphs. Now, you recognize too that the graphs are functions because it said interpreting the function. But overall, we got this, guys. So the concept, functions, the skill is interpret, and let's get this thing started, guys. All right. So first thing I recognize is just 4 problems. Yes, guys. Interpreting graphs of functions. So we have 4 situations going on. We're going to talk about each of them. And right now, you can recognize the vocabulary that's going to be dealt with here. Linear, nonlinear, symmetry, positive, negative, increasing, decreasing, extrema. So let's get it, guys. Identify the function graph as linear or nonlinear. Then estimate and interpret the intercepts of the graph. Any symmetry, where the function is positive, negative, increasing, and decreasing, the x-coordinate of any relative extrema, and the behavior of the graph. So let's start with a pause right now. And when I say a pause, guys, just a second to talk about what we're talking about. So we're basically about to look at a graph, look at a function. We're going to talk about as much as we can. And I'm going to tell you now, we're going to see the answers here. I'm literally going to bring in the answers, something that can be done easily. So I'm going to pop in the answers. The answers are going to look interesting, but using that to explain each and every one of the things that they're asking us, right? So when I say the things that they're asking us, is it increasing or is it decreasing? They're asking us, is it linear or nonlinear? Does it form a straight line or is it some type of curved line? Or another type of curved line, right? It's also asking us, is it positive or negative? And of course, symmetry. So the word symmetry, symmetric. So if you were to draw a line down the middle, would it look exactly the same on the left and the right? Is it a mirror of each other? So with that said, guys, I'm gonna probably pause again after each one or, talk about the answer because again, we're interpreting. What do you see? And the first thing I see is David's savings for the car, right? So let's get playing. Talk about what's going on with number 1. So with number 1, guys, David's savings for the car. And I can literally see and say that, how do we put this? There's weeks and there's savings. So how much is he saving per week? Guys, first thing, is it linear or nonlinear? It is definitely linear. Now, the y-intercept is 1,400. So saying he started with $1,400, guys. So he had $1,400, then he started saving each week. And then each week he saved more and more. So it's a positive increase for x is greater than 0, right? Because he started with $1,400. Here you go, there's $1,400 for your car. Now that's not enough, so you better start saving. So the minimum is $1,400 at 0 because that's what he started with, and he continues to increase and save his money. So that was my interpretation of the graph. I can say that after 10 weeks, he'll have about or over $2,200. It's no line of symmetry. There's nowhere on that graph that I could draw a line going down it where it looks exactly the same on the left as it will on the right. So again, guys, we're talking about the things that we know. You see me highlighting all of the things we just talked about. Was it linear or nonlinear? Was it symmetric? And of course, the end behavior of the graph. So at the end of this function, at the end of the graph, what do we see? Well, we see 2,200 and we see 10 weeks. So after 10 weeks, $2,200 is how much he should have saved up for his car. So we're interpreting the graphs, right? And there it is, highlighted, 2,200 in behavior. And extrema too. So the extremes could be, 2,200 is extreme, like far out, right? Or the 1,400 is what he started with. So, but 1,400 is also known as your y-intercept because that's where it crosses the y-axis. All right, looking at the second one, what's going on here? I see a title of baking supplies. Somebody's about to start baking Hope's cupcakes, or cheesecake. No, cheesecake isn't baking. All right, you get the point. Anyways, what we got going on? We're highlighting the y-intercept at 20. Well, is it linear or non-linear? Yes, it does have it is a straight line, so it is linear. And I do have an x-intercept at 20. I have the x-intercept is 10. The y-intercept is 20. So let's get a pause real fast as we see one more thing here real fast. What's we got here? And behavior of the graph. So quick pause. And again, why do we pause, guys? Because we're talking about what's going on. We're interpreting the graph. So slowing down and making sure that what you see is what you understand, right? So what do I see? I see a line going down. And if it's going down, decreasing, right? So this function is decreasing. That's answering one of the questions right there. What else do I see? I see the y-intercept, and the y-axis is flour, right? The x-axis is batches of cookies. So I can tell you, right, how many batches of cookies I can get for how many things of flour and all of that good stuff. So as we look at it again, guys, what are we trying to find out? Linear or non-linear? We got that. Yes, it is linear. Estimate and interpret the intercepts of the graph. So we do have a y-intercept and we do have an x-intercept. The y-intercept is for cups of flour, 20 cups of flour, all right? And as it decreases, right, all the way down there to the x-intercept, which looks like 10, all right? So y-intercept is 20, x-intercept is 10. We can interpret that. What does that mean, right? No line of symmetry again. So again, there's no line that I can draw that will mirror what's on the left side, the same on the right side, or what's on the top is on the bottom. And we'll see that in just a second. Positive and decreasing. Well, positive and decreasing. So what is positive and what is decreasing? Well, it is a positive, starting with 20, stays in the positive area. There's no negatives at all going on here. Can't have negative cups of flour or negative batches of cookies, of course. But it is decreasing. The maximum is 20 cups at time of 0. Amount of flour will decrease until it is gone. So of course, if I'm baking cookies, eventually I'm going to run out of supplies, right? So if I started with 20, and then I keep using it, keep using it, keep using it, keep using it, till there's nothing left. That's what we're looking at, guys. So, one more time. Maximum is 20 cups at time 0. Amount of flour will decrease until it is gone. See students work for interpretations. So guys, it's said that twice. See student work for interpretation. So you have to do this interpretation. And honestly, it's going to be hard for you to be wrong unless you're just way off in what you're reading. But understanding what the y-axis is, understanding what the x-axis is, and then of course how that graph describes what's happening here. So they're not saving for the car in this one, they are using supplies. And as they use the supplies, they deplenish. But as the supplies deplenish, yeah, we got that. The amount of cookies increases. So there's where it's a positive decreasing, right? Feels good, looks good. Let's get this thing started again. So, a little bit more time, I think. Extrema, again, any extreme values going on here. And of course, yeah. Let's take a look at number 3. Wow. Height of a golf ball. You guys golf? Believe it or not, I'm golfing today. Don't laugh, I do golf. The bearded math brother has a handicap. So, Height of the golf ball. What am I looking at here? What the answer's already there. Doesn't matter. Get it. Come on, slide it. It's good. We're gonna leave it right there. Good for me. So guys, height of the golf ball. Oh, distance from the tee and height. I see what we're talking about here. Well, some of the things I already recognize are intercepts. It's going to cross the y-axis at 0, and it looks like it's crossing the x-axis at 120. And I finally have a line of symmetry. That line drawn right there in red is my line of symmetry. And you see it's approximately 60. Line of symmetry, x is approximately 60. And that's where I'm talking about what's on the left looks exactly like what's on the right. What else am I noticing here, guys? Well, what's the highest point? Same way we looked at the highest point of the savings for the car and the highest point of the flower. Well, this is the highest point of the golf ball. It's going to go 140 feet high. It's pretty cool, right? And what about the distance, right? That's how far does it go? Well, the distance will be the y-intercept. And hold on. Let's get another pause. We're not done interpreting 3. Because, like I said, guys, we're gonna have a short video, but it's only short because there's 4 problems. We're just interpreting, not a lot of math going on. So as I continue, let's just go through the answer that is given by the textbook, and then we'll let you interpret it yourself in your own homework if you're doing this for homework, right? Non-linear, I forgot to mention that. That is not a straight line. It is curving, right? So it's not linear. We do have a y-intercept approximately 0. Doesn't say exactly, doesn't say equal, approximately, right? X-intercept is approximately 0, right? But it also has an x-intercept at 120. So again, 2 intercepts for the x-axis. You can have that. Line of symmetry, we did talk about. X is about 60. The height goes from low of 60 feet to a high of about 145 feet. I believe I said 140. It was a little off. Increasing from 0 to 60 yards from the tee. So that's me, of course, describing how that point, that red one, will work out. It will take 60 yards to get to its highest point. That's interpreting the graph. What's going on at that highest point of the graph? I just told you. What else can we interpret? Last thing. Then decreasing back to 0 from 60 to 120 yards. See students' work for interpretation. All right, guys. Sounds good to me. Hope it sounds good to you. And of course, ask questions, right? When you get back in class and see if your interpretations were similar to any others in your class, because we learn together, y'all. So definitely use your classmates if you got the opportunity. Let's get it moving. So we're looking at 4 now, guys. And again, you're gonna see me highlight. You're gonna see me indicate. So non-linear, doesn't be a straight line. Do we have any intercepts for the y-axis? Absolutely. And since it's there as an answer, -6 1/4, right there, pointed to. Line of symmetry about the y-axis. So there is a line of symmetry. It actually is, straight up. It's the y-axis. Ooh, I see me underlining minimum. So the minimum down there is the same as my y-intercept. But we also have to describe our x-intercepts, right? -12.5 and a +12.5. But again, what's going on here? We didn't even talk about the title of this graph, of this function. Solar reflector, the height and the width. Oh, okay, so literally a solar reflector, the sun, solar, and reflector, bounces off of it. So that's what we're talking about. But again, interpreting the graph. What else do I recognize is happening here, guys? Got the y-axis, got the y-intercept, got the x-intercept. We talked about the line of symmetry. Now, positive or negative, right? Well, it is positive. What's going on here? Where is it positive? Positive for x is less than 12.5. So if you can find 12.5 on there, on the x-axis, right? You'll notice that it starts to go above the x-axis, only at 12.5. Everywhere else, it's below the x-axis, meaning it's negative, right? So where x is less than 12.5 and x is greater than 12.5. That's where it's positive. All right. And the minimum, we already talked about that. Negative 6.25 at 0. So, and again, interpreting the width compared to the height. So again, a function, input, output, right? So if it's a certain height, it's got to be a certain width, and they're basically describing it in this graph. So overall, guys, again, that last sentence, see students work for interpretations. So I'm going to wrap up with explaining it this way. If I was in class and I had my 30s group, when I was in class and I had to help my students understand this lesson, I broke it down as easy as I could. Similar to what we have here, guys, the handout asks the following. Let's do this. Identify the functions graphed as linear or nonlinear. That's one question. Got one thing to do. Then estimate and interpret the intercepts. What are the intercepts? That's the second thing to do. So basically 1, 2 problems. Is it linear, nonlinear? Then next question, what are your intercepts? Any symmetry, third question, where the function is positive, negative, increasing, and decreasing. So kind of the same thing as a positive, negative, increasing, and decreasing. So again, when he was saving for the car, that was positive and increasing, right? So that's the fourth question. And lastly, the x-coordinate of any relative extrema. X-coordinate of any, so again, the highest point of the golf ball, right? The thing was at 60 yards. And then this, number 4, right? The highest width, or when the width becomes positive, right? And then the last question, guys, end behavior of the graph. So literally it's about 6 little questions you just gotta kind of answer. And if you're interpreting your graph and you answer 3 out of those 6, you still interpret it. Your graph, your function, that's good. And then of course you can get better by understanding more of the graph. So guys, nice short video today. We didn't do distributive property, we didn't collect like terms, we didn't graph. We basically looked at a picture of a graphed function and we described what we understood. Great work today, guys. I appreciate you coming and watching the B&B. Don't forget to check out some of the friends. I'll be seeing you guys in the next video.